Hello, everyone, and welcome back. Thank you for staying with us all day and also yesterday. We really, really appreciate it. We want you guys to remain as engaged as before, ask questions. We have a fantastic program in this session, and we're going to kick off with Dr. Kai Keller with Notion Systems, and he'll be telling us about the impact of inkjets in electronics production. So you have 20 minutes, Kai. The stage is now yours, and yeah, good luck.
Thank you, Kasha. Thank you for introducing and thank you for having me. I'm going to talk about impact with inkjet in electronics production. And first of all, let me tell you what we do at Notion Systems. With our industrial inkjet systems and process solutions, we supply key high-tech industries and support the world's leading manufacturers to produce their products in a more ecological and economical way. So this is mainly done by reducing process production steps, which leads to reduced energy consumption and reduced material waste. So that's Notion Systems in a nutshell. Let me give you an outline of my talk. It's a quite general talk about electronics production. I'll talk about how electronic devices work, how they are manufactured usually, and how we reduce process steps by additive technology. What is the contribution of Notion Systems and the process scale-up and production solutions. And last not least, I'll give a short glimpse on one or two processes that we realized so far. Okay, so how do electronic devices work? So if you look at electronic devices, no matter if it's a transistor, an OLED display, or a printed circuit board, they are all made up of structured functional layers. So it can be oxides and metal layers or non-conductive layers. They're all functional, they're all structured. But so how are they manufactured? They're more often than not, they're manufactured in the so-called lithographic process chain, which means that you take a substrate on the top left, you see the substrate, you apply the functional layer on the whole substrate, then you apply in the resist again on the whole substrate, you expose the resist with some LDI or some mask-based process, then you develop the resist, then only in the fifth step, the actual functional layer is structured, so it's etched. And after that, you need to strip the resist to get a functional layer on your substrate. So quite long process chain. And this is also the main reason why manufacturing of electronics is a quite wasteful undertaking. So if you look at the numbers, a large semicon fab for example, needs a lot of water, about 10 million gallons per day, which is about the same amount as 300,000 households. So it's a quite wasteful undertaking. So reducing process steps in production is key. And if you look at additive processes, what can additive processes do in production? We see, or at Notion System, we've realized two classes of applications. First class of applications is quite easy, or yeah, at least lower hanging fruits is by printing, for example, an edge resist, assuming that the structural dimension that you need for your manufacturing process can be printed. So it should be above roughly 20 micron, 20, 30 micron is something that you can't print with inkjet. And then you can apply the resist directly on the functional layer without changing the functionality of the layer itself. And you structure or have already reduced your production by two steps, and which is already making a positive impact on sustainability of electronics production. Of course, as I mentioned, the dimension of the structure should be printable. So what we can't do is producing chips, but there's a lot of many applications